For his astonishing commitments to the fields of material science, Kaku has genuinely mentioned that the James Webb Space Telescope has seen 6 enormous plans that experts acknowledged were unequipped for existing. These appraisals have the genuineness to open up new perspectives on the way in which we could unravel the universe. The straightforwardness is both enamoring and unassumingly challenging, testing existing speculations about the new turn of events and improvement of universes. It infers an extraordinary arrangement to pay unique consideration to these updates, and the insistence by such renowned subject matter experts highlights the significance of these revelations. Kaku is an amazing figure in the logical field. A physicist of American and Japanese legacy, he is seen as an expert in both standard material science and quantum mechanics. Unlike some more moderate and precarious experts, Kaku has been open to the extraordinary potential outcomes of the James Webb Space Telescope mission. His energy to embrace new disclosures and share them with the public demonstrates his commitment to advancing our comprehension of the universe. We are thankful that this prominent master has chosen to end his quiet and straightforwardly share what can no longer be denied. The force and clarity of the striking physicist are evident in his remarks on the discoveries made by the James Webb Space Telescope. These findings suggest that this advancement has reignited his interest. Join us as we explore the repercussions of Kaku's transparency about these 6 titanic plans. Kaku is a master who has consistently considered new theories. Throughout his life, he has shown a responsiveness to ideas that challenge conventional thinking, understanding that Einstein's theories of relativity and Newton's laws, while fundamental, are limited in fully grasping the universe's intricate design. Kaku believes that the discoveries of the new telescope could push the field of cosmology forward. However, many of his colleagues still cannot embrace this view. This has caused concern and trepidation among Big Bang researchers and critics of quantum mechanics, but this only draws laughter from Kaku. The James Webb Space Telescope has revealed 6 colossal universes tracing back to the earliest seasons of the universe. Each of these massive systems contains more stars than our own Milky Way, despite having formed just 200 to 700 million years after the Big Bang. The group of cosmologists who made the discovery has named these brilliant cosmic systems universe breakers. If confirmed, they would significantly change how we understand the universe. The results of these discoveries are profound, suggesting that the universe's early years were far more dynamic and complex than previously thought. The theory of the Big Bang tells us that the universe was chaotic in its infancy. Solid objects took a long time to form, and it took even longer for these objects to reach sufficient density and produce light. The development of complex structures like galaxies was thought to have occurred much later. Some of the recently discovered colossal systems surpass the Milky Way in size, and their immense brightness suggests they were likely forming many new stars each year, whereas our galaxy forms stars only sporadically. It remains unclear precisely when the first structures formed, and researchers have not yet resolved this. One thing is evident. In the beginning, there may have been only individual stars or groups of stars that eventually coalesced into larger structures over time. Smaller systems supported larger, more massive structures. Previously, it was believed that such vast and complex systems were incapable of existing at that time. This raises the question of whether the universe is much older than previously acknowledged or if such large systems formed significantly sooner than anticipated. This scenario is challenging to reconcile with conventional science, which still finds issues with this model. Some areas of material science have explicitly dismissed these discoveries and questioned the accuracy of age estimates. Kaku is aware of this and had this to say: "There are various models and outdated theories that persist due to the influence of certain well-informed experts. Many of these theories were scientifically debunked when fundamental research revealed their flaws. The reality in any science, particularly in material science, lies with the work of experimentalists who keep the theory sharp and on track." He continued, "Here on Earth, we have very little knowledge about the true origins of the universe. This explanation underscores the importance of continuous testing, updating, and reaffirming in the scientific process. The theory of the Big Bang was first proposed in 1927, based on observations of the universe's expansion. This data led to the conclusion that the universe began from a single, infinitely dense point and has been expanding ever since. At the time, it was challenging for people and scientists to imagine a universe with both a beginning and an end. The possibility of a timeless universe was incomprehensible. Even today, scientists still struggle to fully grasp it. However, it is essential to consider these possibilities, even if the new discoveries do not align with what experts have accepted for decades. As to the theory of the Big Bang, science has shown many times that reassessment and openness to groundbreaking ideas are essential to the scientific process. For example, when Einstein was young, it was once believed that stars and planets were fixed in the universe and occupied defined spaces. Yet, now we know that everything in the universe is in motion. Planets orbit stars, stars move within their galaxies at rates of several kilometers per second, and entire galaxies move rapidly through the universe, whose ultimate fate we still cannot predict. His surprising understanding of the universe challenges long-held beliefs and highlights the need for continuous inquiry and adaptation in our scientific thinking. Today, scientists are challenged to recognize inconsistencies and establish that theories are insufficient until they have been thoroughly tested or confirmed by observational data. The idea of the Big Bang emerged from the observation that galaxies are moving away from one another, with their distances proportional to their separation from Earth. This understanding, known as Hubble's law, suggested that the universe was expanding over time. Factors like cosmic microwave background radiation, the redshift of light from distant galaxies, and other cosmological patterns appeared to support this theory. However, it is critical to remember that past generations, who believed the Earth was flat or that the Sun revolved around it, also had observational evidence for their beliefs until new events or technological advancements provided a clearer picture. Currently, we are witnessing a similar situation. Experts expected the James Webb Space Telescope to confirm questions related to the Big Bang theory, but instead, it may have countered these assumptions with the discovery of 6 colossal systems that seemed impossible. This demonstrates that science is continuously evolving and that researchers must remain open to new discoveries and revise existing theories based on available evidence. The astonishing revelations have tested current understanding and prompted a reevaluation of long-standing cosmological theories. Scientists use redshift as a tool to calculate various measurements in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as light sources and observers move relative to one another. To understand this, imagine stopping and hearing a vehicle approaching. As the vehicle gets closer, the engine's sound grows louder, but as it passes and moves away, the sound changes. This occurs because the sound waves compress or stretch based on the vehicle's motion. The same principle applies to light. When a light source, like a distant star, moves closer, the light shifts to bluer tones. Conversely, when the light source moves away, the light shifts to redder tones, a phenomenon called redshift. Physicists have converted redshift values into speeds and distances for measurements in the study of the universe. However, even a small error in these calculations can have significant consequences. The prior assessment methods are now under review. The latest discoveries related to our universe require careful consideration of whether they are truly based on redshift errors or if some scientists are simply dismissing current realities. This is a question that necessitates careful evaluation and a thorough review of the data and methods used in the research. The ongoing evaluation and reassessment of measurement techniques highlight the evolving understanding of scientific inquiry. Thank you for reading this comprehensive exploration of these groundbreaking revelations. As always, we encourage you to share your thoughts in the comments section. If you enjoyed this discussion, please share it so that it reaches more people. Additionally, subscribe to stay updated on more engaging content like this. The study of our universe, with its vast distances and complex phenomena, continues to astonish and challenge scientists worldwide. From early hypotheses about the cosmos to the latest discoveries enabled by cutting-edge technology, every revelation reshapes our understanding of the universe and expands the boundaries of human knowledge. The investigation into our universe's origins and the evolution of galaxies remains one of the most profound and enduring questions in cosmology. Galaxies, akin to massive cities of stars, gas, dust, and dark matter bound together by gravity, hold the keys to unraveling the mysteries of the cosmos. Understanding their formation and development is critical not only for unraveling the universe's secrets but also for testing and refining existing theories. The Big Bang Theory, proposed nearly a century ago, suggests that the universe began from a single, infinitely dense point and has been expanding ever since. This idea emerged from observations of the universe's expansion and the cosmic microwave background radiation, considered remnants of the early universe's intense energy and light. However, recent discoveries, particularly those made by the James Webb Space Telescope, have challenged several fundamental concepts central to the Big Bang Theory. The James Webb Space Telescope, with its extraordinary sensitivity and resolution, has identified galaxies that appear far larger and surprisingly developed for their age. One such discovery includes 6 massive galaxies dating back to when the universe was merely 200 to 700 million years old, a brief moment in its 13.8 billion-year history. These galaxies, nicknamed universe breakers by the research group, defy conventional thinking, as they are already so large and luminous at such an early cosmic age. The discovery of these systems raises intriguing questions about the rapid evolution of the early universe and challenges existing models of galaxy formation. According to prevailing theories, galaxies form slowly over billions of years through the merging of smaller systems and the accumulation of gas and stars. The presence of these enormous systems so early in cosmic history suggests a far more complex and potentially faster process of galaxy development than previously thought. Moreover, these discoveries underscore the pivotal role of technological advancements in reshaping our understanding of the universe. The James Webb Space Telescope's ability to peer deeper into space and capture faint light from distant galaxies has allowed astronomers to uncover previously invisible aspects of the universe's early development. These insights provide valuable clues about the conditions and processes that governed galaxy formation during the universe's infancy. The implications of these findings extend beyond cosmology. They challenge scientists to revisit and refine existing cosmological models to better account for the observed diversity and complexity of galaxies over vast timescales. They also emphasize the dynamic and ever-evolving nature of scientific knowledge, where new discoveries can drive future breakthroughs and open new avenues for research. As scientists continue to examine and interpret the data from the James Webb Space Telescope and other observatories, the study of galaxy formation remains an exciting and rapidly advancing field. Each new discovery brings us closer to unraveling the mysteries of our origins and enhances our understanding of the fundamental processes that have shaped the universe as we know it today.